Out there in the endless darkness, where the icy void of space stretches beyond imagination, something impossible just flickered into existence. Astronomers recently picked up a signal, not from a distant star or a passing comet, but from the frozen edges of our own solar system. Near Neptune, buried in the whispers of cosmic radiation, an energy signature defies all known laws of physics. It pulses like a beacon, radiating the unmistakable fingerprints of cold fusion, a technology we've barely begun to grasp here on Earth. But this wasn't created in a lab or by human hands. The chilling question lingers: if we didn't make it, who did? This isn't just another blip on a telescope's readout. It's a cosmic anomaly that could rewrite everything we think we know about energy, about life, and about our place in the universe. Cold fusion, the stuff of science fiction, the elusive dream of limitless power. Somehow, it's happening out there in the freezing depths near Neptune, where temperatures plunge hundreds of degrees below zero. The laws of physics say it shouldn't be possible, and yet the data doesn't lie. Something or someone has unlocked the secret, leaving behind a trail of energy so advanced, so precise, it feels like a message meant for us. But to understand it, we'll need to venture into the unknown, to the edge of our solar system, and beyond the limits of what science can explain. So let's go on that journey together. Picture the vastness of space, the quiet hum of Neptune's storms, and then a flicker, a burst of energy where none should exist. What does it mean? Is it a natural phenomenon we've never seen before, or evidence of something far more extraordinary? The answer could change everything, because if this signal is what some scientists fear or hope it might be, then we're not just staring at a mystery. We're staring at the future, and it's closer than we ever imagined. Strap in, we're about to dive deep into one of the most thrilling enigmas the cosmos has ever thrown our way. The story begins with a routine scan of the outer solar system by the James Webb Space Telescope, humanity's most powerful eye on the cosmos. On March 15, 2024, while sweeping its infrared gaze across Neptune's icy domain, the telescope's sensors caught something impossible: a spike of energy in a region where nothing should be generating heat. At first, scientists at NASA, a jet propulsion laboratory, assumed it was an instrument glitch. But when they cross-checked with the European Space Agency's Gaia satellite and Chile's ALMA radio telescope array, the signal only grew stronger. This wasn't random noise. It pulsed with eerie regularity, like a heartbeat in the void. What made this discovery so shocking wasn't just its location near Neptune's methane-rich winds. It was the energy signature itself, a near-perfect match for theoretical models of cold fusion, the holy grail of clean power. Unlike the chaotic bursts of solar flares or the steady glow of distant stars, this signal carried the precision of engineered output, as if someone had fine-tuned it. Even stranger, the energy levels defied known physics. In the bitter cold of deep space, where atoms should barely move, the readings suggested particles were fusing at room temperature, releasing energy without the crushing pressures or extreme heat required in conventional fusion. The team behind the discovery, led by astrophysicist Dr. Elena Vasquez, spent weeks ruling out every possible explanation: cosmic rays, instrument malfunctions, even secret military experiments. None fit. What they found instead was a pattern. The signal repeated every 47 hours, pulsing like a metronome, and its frequency shifted subtly over time, almost as if adjusting itself. When word leaked to the broader scientific community, theories erupted. Some proposed an unknown quantum phenomenon. Others whispered the unthinkable, that the signal might be artificial. Because if nature didn't create this, then someone or something did. And that realization sent a shiver through the entire astronomy world. Cold fusion sounds like something ripped straight from a sci-fi novel, but the science behind it is both simpler and more revolutionary than you might think. Unlike traditional nuclear fusion, the process that powers our sun, cold fusion doesn't require extreme heat or pressure to force atoms together. Picture the sun for a moment. Its core is a raging inferno, reaching temperatures of 15 million degrees Celsius, where hydrogen atoms smash into each other with enough force to fuse into helium, releasing colossal amounts of energy. That's stellar fusion, and here on Earth, we've struggled for decades to replicate those conditions in massive, expensive reactors. Cold fusion flips that script entirely. Instead of battling unimaginable heat, it suggests atoms can fuse at or near room temperature, whispering to each other in ways we don't fully understand yet. Think of it like a secret handshake between particles, a delicate, precise interaction that sidesteps the brute force approach of traditional fusion. Scientists call it low-energy nuclear reactions, or LENR, and if harnessed, it could unlock clean, limitless energy without radioactive waste or dangerous meltdowns. No wonder it's been called the Holy Grail. A single gram of fuel, theoretically, could power a home for years, but here's where the Neptune discovery throws everything into chaos. Cold fusion, if it even exists, should require carefully controlled lab conditions, special metals like palladium, precise electrical currents, and human hands fine-tuning every variable. Out in the frozen void near Neptune, where temperatures hover around -200 degrees Celsius and no labs exist, the rules shouldn't apply. And yet, the energy signature detected there matches the theoretical profile of cold fusion almost perfectly. It's like finding a lit candle in the middle of a blizzard, still burning against all logic. The implications are staggering. If this is natural, it means the universe holds physics we've never dreamed of, a hidden chapter in the laws of energy. But if it's artificial, that's a paradigm shift of another kind. Either way, Neptune's cold fusion signal isn't just a curiosity. It's a challenge to everything we think we know, a cosmic puzzle begging to be solved. And whoever, or whatever cracked this code first, might hold the key to humanity's future among the stars. Neptune isn't just another stop in our solar system, it's a cosmic outlier, a frozen giant spinning in the quietest, darkest reaches of our celestial neighborhood. Located an average of 2.8 billion miles from the Sun, it's so far away that sunlight takes over 4 hours just to reach its icy clouds. This isn't the kind of place you'd expect to stumble upon an energy breakthrough. And yet, here we are. To understand why this discovery is so baffling, we have to dive into the unique quirks of Neptune itself, a world where the rules seem to bend in ways we're only starting to grasp. Take its magnetic field, for example. Unlike Earth's relatively stable, symmetrical field, Neptune's is chaotic, tilted at a bizarre 47-degree angle and offset from the planet's core. It's as if the magnetic field has a mind of its own, wobbling unpredictably as the planet rotates. Some scientists speculate this turbulence could create strange pockets of energy, twisting space itself in ways we don't yet understand. Could these magnetic anomalies be linked to the cold fusion signal? It's a long shot, but in a place as peculiar as Neptune, even the wildest theories deserve a second look. Then there's Triton, Neptune's largest moon, a world that defies convention in its own right. Unlike most moons in the solar system, Triton orbits backward, a telltale sign it was likely captured by Neptune's gravity long ago. But here's where it gets interesting. Triton is geologically active, with cryovulcanos spewing nitrogen ice into space. Beneath its frozen crust, many researchers believe a hidden ocean sloshes, a salty, subterranean sea kept liquid by tidal forces. If cold fusion requires precise conditions, could Triton's underground ocean or its volatile surface be part of the equation? The idea isn't as far-fetched as it sounds. After all, water, even in the form of ice, can behave in bizarre ways under extreme pressure, and Neptune's environment is as extreme as it gets. But there's another, even more tantalizing possibility: exotic matter. In the crushing cold and immense pressure of Neptune's atmosphere, hydrogen molecules might compress into strange, metallic forms, creating states of matter that don't exist anywhere else in the solar system. Some physicists theorize these exotic hydrogen phases could trigger nuclear reactions at low temperatures, acting like a cosmic cheat code to bypass the usual rules of fusion. If true, Neptune might not just be a passive backdrop for this discovery, it could be an active participant, a natural laboratory for processes we've never witnessed before. So why Neptune? Maybe it's the chaotic magnetism, the hidden oceans, or the exotic matter lurking in its depths. Or maybe it's something we haven't even considered yet. Whatever the answer, one thing's clear: this isn't a random blip in the void. Neptune, with all its mysteries, seems almost designed to keep secrets. And if cold fusion is happening there, of all places, it's not just a scientific curiosity, it's a clue, pointing us toward truths we're only beginning to imagine. The idea that this baffling energy signature near Neptune could be alien technology isn't as far-fetched as it might seem at first glance. Consider the parallels with other cosmic mysteries that have left scientists scratching their heads. Take fast radio bursts, for example, those split-second, ultra-powerful blips of radio waves from distant galaxies. When they were first detected, some researchers floated the possibility of alien origin, though most now believe they come from natural sources like magnetars or collapsing neutron stars. Or think back to Oumuamua, the first known interstellar object to pass through our solar system. Its bizarre acceleration and unusual shape sparked wild speculation, with Harvard astronomer Avi Loeb famously suggesting it could be an alien light sail. While mainstream science leans toward natural explanations, these cases remind us that the universe is full of phenomena we don't yet understand, phenomena that sometimes push us to consider the extraordinary. Now, let's apply that same skepticism and wonder to Neptune's cold fusion signal. On one side of the debate, you have scientists arguing for a rare but natural explanation. Perhaps it's an exotic form of quantum tunneling, where particles bypass the usual energy barriers through sheer probability, allowing fusion to occur in the deep cold. Maybe Neptune's turbulent magnetic field is acting like a cosmic particle accelerator, creating fleeting conditions ripe for low-energy reactions. After all, nature constantly surprises us with processes we once thought impossible. Superconductivity, quantum entanglement, even the sheer existence of black holes, all were once dismissed as scientific fantasy until we found them woven into the fabric of reality. But then there's the other side of the argument, the one that sends a thrill down your spine. What if this signal isn't natural at all? The precision of its pulses, the way its frequency subtly shifts over time, these aren't hallmarks of random cosmic noise. They're characteristics of engineered systems. Imagine an advanced alien civilization harnessing cold fusion not in sprawling power plants, but in compact, self-adjusting devices. Maybe this signal is leakage from a probe or beacon, something left drifting in Neptune's orbit long ago. Or perhaps it's an intentional transmission, a way for someone or something to announce their presence without the complications of direct contact. The timing adds another layer of intrigue. Humanity is just beginning to crack the first rudimentary prototypes of cold fusion in labs. What are the odds that nature would coincidentally reveal this very process in our own solar system, right as we're on the cusp of understanding it? It's the kind of eerie synchronicity that fuels conspiracy theories, but also genuine scientific curiosity. After all, if an alien civilization did master cold fusion, why wouldn't they use it? It's clean, efficient, and leaves no radioactive traces, the perfect energy source for a species mindful of their cosmic footprint. Of course, the scientific method demands we exhaust every natural explanation before leaping to conclusions about alien technology. But here's what's truly fascinating. Whether this signal turns out to be natural or artificial, its mere existence forces us to confront the limits of our knowledge. If it's natural, we've uncovered a new law of physics hiding in plain sight. If it's artificial, we're not alone, and the implications of that revelation would dwarf every discovery in human history. So as the debate rages on, one thing's certain: the truth, whatever it may be, is out there near Neptune, pulsing quietly in the dark, waiting for us to understand it. Let's crack open the data like an interstellar treasure chest and examine what exactly makes this energy signature so unsettling. The first clue lies in its frequency, around 4.6 terahertz, a range typically associated with molecular vibrations in certain exotic materials, not cosmic radiation. That's like tuning your radio to a static-filled station and suddenly hearing a perfect, pulsing melody where only noise should exist. Even more baffling. The signal's intensity fluctuates in a precise, repeating cycle every 47 hours, as if someone or something is methodically adjusting a dial. Graph the readings over time, and you'll see a near-perfect sine wave, its peaks and valleys mirroring each other with eerie symmetry. Nature rarely creates patterns this clean without intervention. Now zoom in on the spectral analysis and things get even stranger. Most cosmic energy signatures, like those from pulsars or black hole jets, show broad, messy spikes across multiple wavelengths. But this, it's razor sharp, concentrated in a narrow band with almost no bleed into adjacent frequencies. Picture comparing a campfire's flickering glow to the focused beam of a laser. That level of precision suggests something is filtering or refining the energy output deliberately. Even more perplexing is the absence of expected byproducts. Traditional fusion, whether in stars or reactors, produces telltale neutron emissions and gamma rays. This signal shows neither. Instead, there's a faint secondary emission at 1.3 terahertz, a frequency some theoretical models associate with so-called lattice-confined fusion, where atomic reactions occur inside crystalline structures. Then there's the modulation. Over weeks of observation, researchers noticed the signal's frequency isn't entirely static. It drifts by approximately 0.02%, shifting minutely but consistently. At first glance, that might suggest Doppler effects from a moving source like a satellite orbiting Neptune. But here's the catch: the drift isn't linear. It accelerates and decelerates in a pattern that mirrors Neptune's own rotational wobble, as if the signal's origin is somehow synced to the planet's motion. That's not just unusual, it's unprecedented. Natural phenomena don't lock onto a planet's rotation unless they're physically tied to it, like a moon or atmospheric storm. Yet no known object in Neptune's vicinity matches the signal's location. The final nail in the "it's just space weather" coffin, the signal's bandwidth efficiency. In human-made communication, say, a Wi-Fi signal or radio broadcast, we cram as much data into as narrow a frequency range as possible to avoid interference. This signature does the same thing, occupying less than 0.1% of its central frequency's bandwidth. To find that kind of spectral discipline in nature would be like discovering a snowflake that fell in the shape of a microprocessor. Either we're looking at an entirely new class of astrophysical phenomenon, or we're seeing the fingerprints of a technology, one that treats the laws of physics less like rules and more like suggestions. So what do we make of these clues? The precision, the modulation, the eerie absence of expected byproducts, they all point toward something beyond random chance. Whether it's a naturally occurring quantum fluke or something far more deliberate, one thing's certain: this isn't just another cosmic mystery. It's a riddle wrapped in a neutron star, whispering secrets we're only beginning to decode. And with every new data point, the puzzle only grows more tantalizing. The history of cold fusion is littered with false starts, wild claims, and the occasional glimmer of something truly groundbreaking. So when rumors of a cosmic energy signature near Neptune surfaced, scientists had every reason to approach it with skepticism. Rewind to March 23, 1989, when chemists Martin Fleischmann and Stanley Pons sent shockwaves through the scientific community by announcing they'd achieved cold fusion in a simple lab setup. The world held its breath, imagining endless clean energy until other labs failed to replicate their results, and the discovery was largely dismissed as an experimental error. But here's the twist. In the decades since, a small cohort of researchers has quietly continued studying low-energy nuclear reactions, occasionally reporting anomalous heat or traces of nuclear byproducts they can't fully explain. The mainstream scientific consensus remains skeptical, but the parallels to Neptune's signal are impossible to ignore. Both defy conventional physics, and both refuse to fit neatly into the impossible category. Then there's the cosmic side of the mystery. In 2010, astrophysicists analyzing data from NASA's Chandra X-ray Observatory detected unexplained X-ray emissions near Saturn brief, intense bursts that didn't match any known natural process. Some speculated about exotic plasma physics, while others humorously suggested an alien energy source. The phenomenon was eventually attributed to solar-wind interactions with Saturn's rings, but for a fleeting moment, it showed how even seasoned scientists can be blindsided by the universe's surprises. Fast forward to 2017, when the Breakthrough Listen project picked up a bizarre radio signal from Proxima Centauri, dubbed BLC-1. It bore hallmarks of artificial origin narrowband drifting in frequency before further analysis suggested terrestrial interference. These cases share a pattern, a tantalizing anomaly, a burst of excitement, and then a return to the status quo. But each time, the door cracks open a little wider, nudging us to ask, what if the next one isn't a false alarm? Now consider the bigger picture. Throughout history, paradigm-shifting discoveries often faced fierce resistance before becoming accepted truths. Continental drift, quantum mechanics, even the existence of meteorites, all were ridiculed before evidence became undeniable. The difference this time, we're not just dealing with an obscure lab experiment or a distant cosmic blip. Neptune's signal sits in our celestial backyard, pulsing with a precision that demands answers. Whether it's a new law of physics or something far more extraordinary, one thing's clear: the universe has a habit of humbling our assumptions, and if history teaches us anything, it's that today's impossible might be tomorrow's textbook fact if we're brave enough to keep looking. The Fermi paradox has haunted astronomers for decades, a simple question with terrifying implications. If the universe is teeming with life, where is everybody? Enrico Fermi first posed this in 1950, and to this day we have no satisfying answer. Countless galaxies, billions of potentially habitable planets, and yet silence. That eerie quiet makes Neptune's cold fusion signal all the more electrifying, because if this is a technosignature proof of alien engineering, it doesn't just solve the Fermi paradox. It flips it on its head. Think of the paradox like this: Earth is young compared to the cosmos. If civilizations just a few thousand years older than us exist, they'd have technology so advanced they should have colonized the galaxy by now. Yet we see no megastructures, no fleets of starships, no radio chatter. Some argue this means intelligent life is vanishingly rare, or that civilizations inevitably self-destruct. Others suggest we're looking for the wrong clues, searching for radio waves when advanced beings might communicate through neutrinos or quantum entanglement. But Neptune's signal offers a third option. What if they have left traces, just not where we expected? Technosignatures, detectable markers of alien technology, don't have to be flashing neon signs. They could be subtle, even accidental. Picture a civilization so advanced cold fusion is as mundane as steam power is to us. Maybe their everyday tech leaks energy in patterns we're only now learning to recognize. Or perhaps this signal is deliberate, a cosmic hello designed to be found once we reached a certain level of understanding. After all, if you wanted to communicate with a less advanced species, you wouldn't beam instructions for warp drive at them. You'd leave breadcrumbs clues that only make sense once that species is ready. There's a darker possibility, too. The Fermi paradox's great filter theory suggests some insurmountable hurdle prevents civilizations from spreading across the stars, whether it's environmental collapse, wars, or some unknown cosmic catastrophe. If Neptune's signal is artificial, it might be a relic, a last whisper from a civilization that didn't make it. Imagine stumbling upon a fossilized alien battery, still humming faintly after millennia. The thought is equal parts awe-inspiring and chilling, but here's the most thrilling angle. This could be proof we're not alone and yet still trapped in the paradox. Advanced civilizations might avoid contact not out of malice but caution. Think of humanity's own debates about contacting isolated tribes. Well-meaning interference can bring unintended harm. An alien race might observe us from a distance, leaving only the faintest clues to test our curiosity and restraint. Neptune's signal could be their way of asking, "Are you ready?" The beauty of this discovery is that it reframes the Fermi paradox entirely. Instead of asking why the universe is silent, we're forced to wonder, what if we've been listening for the wrong things all along? The answer to "where is everybody?" might have been hiding in our own solar system, pulsing quietly near Neptune, waiting for us to finally ask the right questions. When news of the Neptune anomaly broke, NASA found itself walking a tightrope between scientific caution and public fascination. The agency's official statement, released on April 2, 2024, was a masterclass in measured language. They confirmed the detection of an unusual energy signature near Neptune, emphasized the need for rigorous verification, and stressed that all explanations, including exotic natural phenomena, remained on the table. But between the lines, the excitement was palpable. Behind closed doors, sources reported emergency meetings at the Jet Propulsion Laboratory, with researchers scrambling to retask telescopes and draft mission proposals. Then came the press conference. On April 9th, NASA Chief of Planetary Science, Dr. Rajesh Verma, stood before a crowded room of journalists and dropped a bombshell. The agency was fast-tracking a flyby mission to Neptune, leveraging existing hardware from the cancelled Triton project to cut development time. Dubbed Odyssey Pulse, the probe would launch as early as 2027, equipped with custom spectrometers designed to analyze the signal source. When pressed about the possibility of artificial origins, Verma offered a coy response. "Our priority is understanding, not speculating, but I'll say this, we've never seen anything quite like it." Meanwhile, across the Atlantic, the European Space Agency took a bolder stance. Leaked internal memos revealed plans to collaborate with private aerospace firms, including a controversial pitch to beam a targeted radio response toward Neptune using Spain's deep space antennas. Critics called it premature, but supporters argued that if the signal was engineered, a carefully crafted reply might trigger further contact. Even China's National Space Administration quietly diverted resources, accelerating work on their Interstellar Express probes, a move interpreted by analysts as a race to claim scientific bragging rights. The scientific community remains divided. Some researchers accuse agencies of ufology creep, fearing legitimate study will be overshadowed by sensationalism. Others point to history's lessons. The discovery of pulsars in 1967, initially dubbed LGM-1, little green men, until their natural origin was confirmed. But this time feels different. Unlike distant pulsars or fleeting radio bursts, Neptune's signal sits in our cosmic backyard, close enough to touch, and that proximity changes everything. Whether it's a natural marvel or something more, one thing's certain. Humanity's gaze is now locked onto that icy blue dot at the edge of the solar system, waiting for the next clue to reveal itself. When news of Neptune's cold fusion signal reached Silicon Valley, the reaction wasn't just curiosity, it was a gold rush in the making. Within hours of NASA's announcement, Elon Musk tweeted a single cryptic line, "Interesting." Fusion without the sun, followed minutes later by SpaceX's official account reposting a 5-year-old concept animation of a Neptune-bound starship with the caption, "Distance used to be a problem." The message was clear: if humanity had just stumbled upon an energy breakthrough at the edge of the solar system, the private sector wasn't about to sit on the sidelines. But Musk isn't the only billionaire eyeing this cosmic jackpot. Jeff Bezos' Blue Origin quickly filed a patent application for a deep space energy harvesting module, while Palantir's Peter Thiel funneled millions into a secretive startup called Helios Frontier, rumored to be reverse engineering cold fusion data. Even Richard Branson's Virgin Galactic pivoted, temporarily shelving suborbital joyrides to announce a partnership with the Breakthrough Initiatives, aiming to develop what they're calling long-range quantum sensors. The race isn't just about prestige, it's about trillions in potential energy revenue. Because if cold fusion works in Neptune's icy void, whoever cracks the code first could dominate power generation for centuries. The real wild card: startups you've never heard of. In a warehouse outside Austin, a company called Exodynamics claims to have already built a prototype reactor using borrowed principles from the Neptune signal's spectral data. Their CEO, a former SpaceX engineer, gave a viral TED talk arguing that fusion isn't a physics problem, it's a materials science challenge. Meanwhile, in Switzerland, a consortium of AI firms is training neural networks to simulate the signal's unique 47-hour pulse cycle, hoping to replicate its conditions in miniature. The private sector moves fast, often blurring the line between genius and recklessness. When one venture capitalist was asked about safety concerns, he laughed. The only real risk is being second. Yet for all the hype, there's a philosophical divide emerging. Some billionaires see Neptune's signal as a business opportunity, others treat it like a cosmic SOS. Y Combinator's latest request for startups explicitly seeks technologies to interpret potential extraterrestrial energy signatures, a polite way of asking, what if someone's trying to talk to us? OpenAI's Sam Altman went further, suggesting on Lex Fridman's podcast that advanced AI should be used to decode the message, not just mine it. The tension is palpable: profit versus knowledge, exploitation versus understanding. What's fascinating isn't just the money pouring in, it's the speed at which the impossible became investable. 5 years ago, cold fusion was a punchline. Today, it's the hottest ticket in tech. And whether these ventures lead to clean energy revolutions or spectacular failures, one thing's certain: Neptune's signal has already changed the game. The stars aren't just for governments anymore. They're for the disruptors, the dreamers, and the downright ambitious, all racing toward that flickering blue dot at the edge of everything we know. Whenever a discovery this monumental hits the headlines, conspiracy theories are never far behind. Within hours of NASA's announcement about Neptune's energy signature, the internet erupted with wild speculation ranging from plausible skepticism to outright sci-fi fantasies. At the heart of it all, a single burning question: if this is alien technology, do governments already know more than they're letting on? History offers eerie parallels. Take the infamous Roswell incident in 1947, when the U.S. military first claimed to have recovered a flying disc, only to retract the statement days later, calling it a weather balloon. Decades of leaks, alleged whistleblowers, and declassified documents have only deepened the mystery. Then there's Bob Lazar, the controversial figure who claimed in the 1980s to have worked on reverse engineering alien propulsion systems at a secret site called S4 near Area 51. Mainstream science dismisses Lazar, but his descriptions of element 115 and gravity-distorting technology now sound uncomfortably close to theoretical physics being explored in cutting-edge labs today. Even more striking are the recent admissions from governments themselves. In 2021, the Pentagon declassified 3 U.S. Navy videos showing unidentified aerial phenomena, objects moving in ways that defy known aerodynamics. While officials stopped short of labeling them extraterrestrial, they openly admitted they couldn't explain them. Fast forward to 2024, and former intelligence officer David Grush testified under oath about covert programs retrieving non-human craft, igniting congressional hearings. Whether you believe these claims or not, one pattern is clear. Whenever credible witnesses step forward, the official response follows a familiar script: initial denial, grudging acknowledgement, then a pivot to nothing to see here. Now apply that pattern to Neptune. Skeptics point out that the signal's discovery coincides with global tensions over energy resources. Could the timing be suspicious? Some speculate that cold fusion has already been achieved in black-budget labs, and this discovery is a staged rollout to prepare the public. Others whisper about a cosmic false flag. What if the signal isn't alien at all, but an Earth-made projection, a test of how humanity reacts to first contact? The wildest theories suggest we're dealing with an ancient alien artifact, something left behind long before humans walked the Earth, and certain governments have known about it for years. But here's where things get even twistier. In 2023, a trove of leaked emails from a senior SA official mentioned anomalous energy signatures near Neptune a full year before the public announcement. The emails were quickly dismissed as taken out of context, but the implications are unsettling. If this discovery wasn't sudden, what else might be hiding in plain sight? And why the sudden urgency to send probes now? The truth is, conspiracies thrive in the gap between what's known and what's unknowable. And Neptune's signal, whether it's a natural wonder, alien tech, or something even stranger, has blown that gap wide open. For every scientist urging caution, there's a whistleblower insisting the lid's about to blow off the biggest secret in history. One thing's certain: where there's this much smoke, people will keep searching for fire. And in the shadowy crossroads of government secrecy and cosmic mysteries, the line between paranoia and prophecy has never been thinner. Not every scientist is ready to rewrite the textbooks based on Neptune's mysterious signal. In fact, some of the most respected minds in astrophysics are pushing back hard against the idea of alien technology, and their arguments are just as compelling as the wilder theories. Take Dr. Miriam Kovac at Caltech, a pioneer in spectroscopy who's spent decades analyzing cosmic anomalies. She recently published a scathing critique titled Neptune's Mirage, arguing that the signal's 47-hour cycle aligns suspiciously well with the rotation period of Triton's cryovolcanic plumes. "We're seeing what we want to see," she warns. Interstellar archaeology makes for great headlines, but Occam's razor still applies: the simplest explanation. A previously undocumented interaction between Neptune's magnetosphere and its moons. Then there's the instrument argument. The James Webb Space Telescope may be humanity's most advanced eye in the sky, but it's not infallible. Dr. Raj Patel at MIT's Kavli Institute points to Webb's infamous, spurious mid-infrared artifact incident from 2023, where a glitch in the MIRI instrument created phantom methane readings near Jupiter. Webb's detectors are hypersensitive to cosmic rays, Patel explains. One high-energy particle striking at just the right angle could simulate a narrowband signal. Until we get corroborating data from multiple independent instruments, not just Gaia and ALMA, which share similar vulnerabilities, this could easily be an elaborate system noise. But perhaps the most intriguing natural explanation comes from quantum physicist Dr. Ilara Voss. Her team at CERN has been running simulations suggesting the signal might be evidence of dark matter catalysis, a theoretical process where weakly interacting massive particles collide with Neptune's atmospheric hydrogen, sparking fleeting low-energy fusion. "We've assumed dark matter is inert," Voss says, but if certain particles act as nuclear catalysts under specific magnetic conditions, Neptune's chaotic field might be the universe's perfect petri dish. It's an exotic idea, yes, but still far more plausible than jump-starting alien tech debates. Even the signal's precision has mundane explanations. Dr. Chen Wei at Beijing's Planetary Science Lab notes that pulsars' natural cosmic lighthouses emit radio waves with clockwork regularity. Magnetars exhibit frequency drifting too, he adds. Just because we've never seen this combination of traits near Neptune doesn't mean it can't exist. Remember, until 1992, we didn't know planets orbited other stars. The cosmos loves proving us wrong. The skeptics all agree on one thing: extraordinary claims demand extraordinary evidence. Right now, Neptune's signal is a tantalizing maybe, a cosmic Rorschach test where some see aliens, others see quantum quirks, and everyone sees their own biases reflected back. Until a probe reaches those icy depths, the truth remains suspended between wonder and doubt, a reminder that science thrives not on answers but on the thrill of the hunt. While the debate rages over whether Neptune's signal is alien technology or a cosmic fluke, one thing is certain: scientists aren't waiting around to find out. Across the globe, labs are scrambling to recreate that mysterious energy signature right here on Earth, hoping to crack its secrets before any spacecraft reaches the icy giant. At CERN, physicists have repurposed the same particle accelerators used to hunt the Higgs boson, running simulations that bombard hydrogen-infused palladium with precise magnetic pulses. Early results: flickers of excess heat, tiny, inconsistent, but enough to make researchers lean in. One team lead, Dr. Luca Morti, describes it as trying to tune a radio to a station that keeps drifting. You catch a note of music, then static, but the fact we hear anything at all, that's what keeps us up at night. Meanwhile, MIT's Plasma Science and Fusion Center took a different approach. Instead of chasing cold fusion directly, they're mimicking Neptune's extreme environment, supercooling reactors to near absolute zero, while bombarding them with artificial magnetosphere disturbances. The goal: see if chaotic magnetic fields can twist physics into submission. Initial data shows bizarre quantum tunneling effects, where particles seem to skip through energy barriers like stones across a pond. It's not quite the 47-hour pulse cycle from Neptune, but as lead researcher Dr. Priya Nandi puts it, we're not replicating the signal yet, we're learning how space might be cheating. Then there's the dark horse, a startup called Hellion Energy, backed by Silicon Valley heavyweights. While academia focuses on fundamentals, Hellion's engineers built a donut-shaped reactor they cheekily dubbed Triton Core, flooding it with deuterium gas and zapping it with oscillating electric fields tuned to, you guessed it, 4.6 terahertz. Their claim: brief energy spikes matching Neptune's signature's harmonic frequencies. Mainstream scientists dismiss it as noise, but Hellion's CEO fires back. Every paradigm shift starts with someone being called a crank. Of course, replicating a cosmic mystery in a lab is like trying to rebuild a thunderstorm in a teacup. Even if researchers achieve similar energy patterns, proving they're the same as Neptune's requires something bigger, a way to bridge the gap between controlled experiments and the chaos of space. That's where facilities like Sandia National Labs come in. Their Z machine, the most powerful pulsed power generator on Earth, can simulate the crushing pressures of Neptune's atmosphere for microseconds at a time. When engineers recently ran a test with metallic hydrogen samples, sensors picked up anomalous neutron emissions, fleeting, but eerily reminiscent of what theoretical models predict for lattice-confined fusion. The takeaway: while no one's recreated Neptune's signal bolt for bolt yet, each experiment chips away at the impossible. Whether it's CERN magnetic puzzles, MIT's quantum shortcuts, or even a startup's moonshot, the race isn't just about bragging rights. It's about answering a question that could define our species. Are we alone in the universe, or is someone or something out there lighting a beacon in the dark? Among Neptune's many oddities, its largest moon, Triton, stands out as a cosmic rebel with a knack for breaking the rules. orbiting backward against Neptune's rotation, a telltale sign it was captured by the planet's gravity long ago. This frozen world is anything but dormant. Triton's surface is scarred with cryovolcanoes, spewing geysers of nitrogen ice miles into the void, while beneath its icy crust, many scientists suspect a hidden ocean sloshes with more liquid water than all of Earth's seas combined. It's a place where the ordinary laws of planetary science seem to bend, making it the perfect candidate for hosting something as bizarre as cold fusion. Take those geysers, for example. When Voyager 2 flew past Triton in 1989, it caught plumes erupting 8 kilometers high, powered not by magma like Earth's volcanoes, but by sunlight vaporizing subsurface nitrogen. The process is like a cosmic pressure cooker. As Triton's erratic orbit brings it closer to the Sun, surface ices heat up just enough to fracture, releasing trapped gases in explosive jets. Now imagine that same energy harnessed and amplified. If Triton's internal tides, generated by Neptune's relentless gravitational squeeze, keep its subsurface ocean liquid, those same forces could be churning minerals and creating electrochemical gradients ripe for exotic reactions. Some researchers speculate that tidal friction might even generate localized hotspots, pockets of warmth in the abyss where the impossible becomes plausible. Then there's Triton's retrograde orbit, a backward loop so unusual that it defies the orderly motion of most moons in our solar system. This backward dance creates intense gravitational interactions, flexing Triton's core like a stress ball. On Jupiter's moon Europa, similar tidal forces are thought to maintain a subsurface ocean by generating heat through friction. But Triton's orbit is far more chaotic, potentially creating even wilder energy dynamics. Picture the way rubbing your hands together generates warmth, then magnify that to planetary scales. The result, a moon that might not just have liquid water, but zones of intense thermal and magnetic activity, perfect laboratories for freak energy phenomena. Compare Triton to Enceladus, Saturn's icy moon famous for its watery plumes. Both worlds eject material from hidden oceans, but while Enceladus' jets are steady and predictable, Triton's eruptions are sporadic and violent, hinting at reserves of pent-up energy. Or look at Europa, where tidal heating creates vast underground lakes. Triton's ocean, if it exists, could be even more dynamic, laced with ammonia or salts that lower its freezing point and create bizarre chemistry. If cold fusion requires specific pressure and catalytic environments, these subsurface seas, briny, turbulent, and packed with minerals, might just check every box. But here's the kicker. Triton's surface is one of the coldest places in the solar system, averaging -235 degrees Celsius. That's the kind of cold that should lock atoms in place, making fusion unthinkable. Unless, of course, something beneath the ice is cheating. Recent models suggest that tidal forces could concentrate heat in narrow fissures, creating temporary pockets where water stays liquid and particles move fast enough to trigger low-energy reactions. Alternatively, Triton's ocean might contain exotic forms of hydrogen like metallic hydrogen under extreme pressure that behave in ways we've never observed on Earth. Whether Triton is the source of Neptune's signal or just another piece of the puzzle, one thing's clear: this moon is no passive bystander. It's a world of contradictions, frozen yet fiery, ancient yet geologically alive. And if there's even a sliver of a chance that its hidden depths are cooking up cosmic secrets, humanity's next mission to the outer solar system just found its first stop. The more we learn about Triton, the more it feels like a vault waiting to be cracked, one that might hold the key to rewriting physics itself. If Neptune's signal is artificial, humanity faces a dilemma unlike any in history. Do we answer back? The question isn't just scientific, it's profoundly ethical, forcing us to weigh curiosity against caution on a cosmic scale. On one side, visionaries like the late Stephen Hawking warned that broadcasting our presence could invite catastrophe. He likened it to Columbus making first contact with the Americas, an event that, for indigenous peoples, ended in devastation. Hawking's fear, an advanced civilization might see us not as peers but as resources or pests. The universe, he argued, is likely full of predators, not pen pals. This chilling perspective aligns with the dark forest theory, a concept popularized by sci-fi writer Liu Cixin but rooted in sober logic. Imagine the cosmos as a vast, pitch-black woodland where every civilization is a hunter hiding in the trees. Making noise, sending signals, announcing your location could draw the attention of something far more powerful. In this view, silence isn't just prudent, it's survival. Proponents point to Earth's own history. Dominant species rarely coexist peacefully with lesser ones. Why assume aliens would be any different? Yet for every warning, there's a counter-argument. SETI astronomer Jill Tarter famously countered that any civilization capable of interstellar travel would have outgrown resource wars. After all, if you can harness the energy of stars, why raid primitive planets? Some researchers suggest advanced beings might follow universal ethical frameworks, perhaps even viewing contact as a duty like passing the torch of knowledge. The very fact that Neptune's signal pulses gently rather than screaming across wavelengths could imply a sender mindful of subtlety. Practical risks muddy the waters further. Even if we want to respond, how do we craft a message that won't be misunderstood? Human history is littered with disastrous translation errors, from Cortés misinterpreting Aztec prophecies to Cold War nuclear false alarms. Now imagine that stakes inflated to interstellar proportions. A simple mathematical sequence might seem universal, but what if prime numbers read as a threat in another culture's logic? NASA Voyager golden records with their pictorial greetings could be as cryptic to aliens as cave paintings are to us. Then there's the timing problem. Neptune is close by cosmic standards, but still over 4 light hours away. A two-way conversation, with each message taking nearly 8 hours round trip, would crawl compared to human patience. And if the signal's origin isn't Neptune itself, but something passing through the region, a probe perhaps, we might be yelling into the void long after the listeners moved on. Perhaps the most compelling middle ground comes from METI International, a group advocating for active SETI, sending deliberate signals but with strict protocols. They propose global consensus before transmitting, like a planetary security council. Their template messages avoid specifics about Earth's location, focusing instead on scientific concepts meant to showcase intelligence without vulnerability. It's a nuanced approach, acknowledging both the thirst for contact and the need for caution. Ultimately, the choice hinges on how we view intelligence itself. Are civilizations destined to compete, or can they collaborate across the stars? Neptune's signal, whether a handshake or a siren song, forces us to confront not just who's out there, but who we want to be. In the silence between pulses, one truth echoes: space isn't just a frontier of discovery. It's a mirror reflecting our own hopes, fears, and the weight of our choices. Theoretical physics offers a fascinating lens through which to examine Neptune's enigmatic signal, one that stretches our understanding of what's possible in the cosmos. Dr. Kip Thorne, Nobel laureate and gravitational wave pioneer, suggests the signal's precision could hint at technologies far beyond our current grasp. Warp drives aren't just science fiction, he explains. The math checks out. If a civilization harnessed negative energy, a hypothetical form of matter with repulsive gravity, they could bend spacetime itself, creating signatures that look like phantom energy pulses to outside observers. Imagine a ship wrapped in a bubble of distorted space, its propulsion system leaking traces of exotic physics as it moves. What we're detecting near Neptune might not be a stationary beacon, but the ripple effects of something passing through. Equally mind-bending is the Dyson sphere hypothesis, a megastructure built around a star to harness its energy, while Neptune lacks a star to envelop Dr. Michio Kaku points out that advanced civilizations might miniaturize the concept. A Dyson swarm, a fleet of energy collectors orbiting a planet or moon, could explain the signal's rhythmic pulses, he says. Each time a collector aligns with our line of sight, we'd catch a flicker of its power output. Triton's chaotic orbit could make such a swarm appear irregular, yet mathematically patterned. The 47-hour cycle, that might be the time it takes for key components to complete their dance around Neptune's magnetic field. Then there's the wild card, quantum vacuum energy. Dr. Sarah Seeger at Anomaly speculates about zero-point energy, the faint buzz of particles popping in and out of existence even in empty space. If you could tap that, she says, you'd have a power source that never runs dry. The catch, extracting it requires manipulating space-time at scales we can't yet fathom. But if a civilization cracked that code, their technology might leave traces resembling cold fusion, energy appearing from nowhere, defying thermodynamic laws. Not all physicists are ready to leap to alien megastructures. Dr. Brian Greene cautions that unknown quantum phenomena could mimic engineered signals. Entanglement, extra dimensions, even flaws in the fabric of space-time, we're still mapping physics' frontier, he notes. What looks like a Dyson swarm to us might be a natural rift in quantum fields. Yet even skeptics agree, whether natural or artificial, Neptune's signal challenges our models, and that alone makes it worth chasing. The universe, it seems, still holds cards we've barely glimpsed, and the game is just getting interesting. Astrobiologists have spent decades searching for life beyond Earth, but their focus has traditionally centered on familiar benchmarks: liquid water, organic molecules, and energy sources like sunlight. Neptune's cold fusion signal throws that playbook out the window. If a phenomenon like this can occur naturally in the frigid depths of space, it forces a radical rethink of what life might look like and where it could thrive. Dr. Sarah Johnson, a leading astrobiologist at NASA Jet Propulsion Laboratory, puts it bluntly, we've been looking for life as we know it, but what if life out there doesn't play by our rules? Consider extremophiles, Earth's own microscopic rebels that laugh in the face of hostile environments. From bacteria thriving in nuclear reactor coolant to microbes buried in Antarctic ice, life on our planet has repeatedly proven it can adapt to the unthinkable. Now stretch that logic to cosmic scales. If organisms can survive boiling acid or crushing ocean pressures, why not a life form that harnesses cold fusion in the methane-rich winds of Neptune? The idea isn't as wild as it seems. Biochemists speculate about alternative life chemistry's organisms built not on carbon and water, but on silicon and ammonia, or even plasma-based entities dancing in the magnetic fields of gas giants. Cold fusion, in this context, might not just power alien civilizations. It could be part of their very biology. Take the concept of quantum life, a fringe but fascinating theory suggesting that subatomic processes like quantum entanglement or tunneling could form the basis of living systems in extreme environments. Picture a life form woven from magnetic field lines, its metabolism tied to the ebb and flow of particles fusing in Neptune's chaotic atmosphere. Or imagine microbial analogs floating in Triton's subsurface ocean, drawing energy not from sunlight or hydrothermal vents, but from nuclear reactions sparked by tidal forces. These scenarios sound like sci-fi, but they're grounded in real physics. After all, if life on Earth can exploit geothermal heat or radioactive decay, why not fusion? The implications ripple outward. If cold fusion is possible in nature, it could solve one of astrobiology's biggest puzzles: how life sustains itself in places devoid of starlight. Europa and Enceladus, with their hidden oceans, are prime targets in the search for life because they're warmed by tidal friction. But Neptune, its icy grip, should be a dead zone. Yet if organisms there tap into fusion, suddenly the coldest corners of the cosmos become habitable. It's a paradigm shift that redefines Goldilocks zones. Forget liquid water. The new frontier might be planets and moons where magnetic chaos and exotic matter collide, creating pockets of energy ripe for life we can't yet imagine. Of course, skepticism remains. Dr. Carlos Mendez, a biochemist at the University of Tokyo, cautions that cold fusion, much less life based on it, is still speculation. Extraordinary claims require extraordinary evidence, he says. Right now, we have a signal, not a smoking gun. But even he admits the discovery forces a thrilling question. If life can emerge in the unlikeliest places, are we arrogant to assume it must resemble us? The universe, it seems, is far stranger and far more creative than we've dared to dream. As the debate rages, one thing is clear: Neptune's signal isn't just a physics problem. It's a challenge to our entire understanding of life's potential. Whether it's the whisper of an alien reactor or the birth cry of a new branch of astrobiology, this anomaly reminds us that the cosmos still has secrets we've barely begun to uncover. And somewhere in that vast darkness, the rules of life may be waiting to be rewritten. The moment news of Neptune's cold fusion signal hit the internet, the digital world erupted in a frenzy of awe, panic, and inevitably memes. Within minutes of NASA press conference, #Neptune Beacon began trending on Twitter, with users oscillating between genuine wonder and absurdist humor. One viral tweet read, "Neptune out here flexing with clean energy while my Wi-Fi still drops when the microwave's on," racking up over 200,000 likes. Meanwhile, TikTok creators jumped on the trend, stitching clips of the announcement with edits of aliens sipping metaphorical tea or Neptune morphing into a glowing energy drink can. The platform's algorithm amplified the chaos, pushing reaction videos of people dramatically dropping their phones in shock, set to the sound of a record scratch. Reddit's r/space thread became a battleground of theories and jokes, with one user overlaying the signal's frequency graph onto a DJ's mixer, captioning it, "Neptune dropping the hottest mixtape of 2024. Another post spliced the discovery footage with a clip from Independence Day, zooming in on Neptune as Will Smith shouts, "Welcome to Earth," but beneath the humor lurked genuine unease. Conspiracy forums lit up with claims of government cover-ups, while some users openly worried what if replying to the signal triggers an alien invasion. A particularly viral tweet captured the duality. "Scientists, this could rewrite physics, my brain at 3 a.m. But what if it's just space Seath whose ringtone?" Artists and digital creators seized the moment too. Deviant art flooded with neon-lit renditions of Neptune pulsing like a celestial rave, while Instagram illustrators reimagined the ice giant as a steampunk power core or a glowing alien motherboard. Even corporate brands couldn't resist. Energy drink companies tweeted mock ad campaigns like, "Neptune's got infinite energy, so do we, #charge like a giant." The line between fascination and parody blurred completely when a viral TikTok filter transformed users' faces into alien energy beings, complete with pulsing terahertz wave eyes. Yet amid the memes, poignant threads emerged. Parents shared bedtime stories they invented about Neptune's mystery light for their kids, and teachers posted lesson plans weaving the discovery into physics classes. One viral post, a photo of a handwritten note from a 9-year-old read, "Dear Neptune, can we be friends? P.S. Do you like pizza?" The internet, in its chaotic way, became a mirror for humanity's collective psyche, equal parts terrified, curious, and desperate to laugh in the face of the unknown. The signal didn't just ignite scientific debate, it became a cultural Rorschach test. For every meme comparing Neptune to a malfunctioning smart bulb, there were earnest discussions about humanity's place in the cosmos. Late-night hosts monologued about interstellar drama, while podcasters debated whether aliens would judge us for turning their beacon into a joke. And through it all, the signal kept pulsing unfazed by the storm it sparked back on Earth, a silent enigma wrapped in layers of humor, art, and existential dread. The internet had spoken. Whatever this discovery meant, we'd process it the only way we know how, together, loudly, and with a heavy dose of GIF. Science fiction has a funny way of nudging us toward the future, sometimes with eerie precision. Think about Contact, the 1997 film based on Carl Sagan's novel, where scientists pick up a repeating signal from Vega, a sequence of prime numbers unmistakably artificial. The parallels to Neptune's pulsing energy signature are uncanny. Both discoveries begin with a quiet anomaly, a flicker of data that snowballs into a paradigm shift. But where Contact imagined a clear, deliberate message, a cosmic handshake, our reality is messier. Neptune's signal doesn't come with an instruction manual or a friendly alien voice. It's a riddle wrapped in static, leaving us to wonder, did fiction prepare us for this moment or set us up for disappointment? Then there's Arrival, the 2016 film where linguists grapple with alien symbols that rewrite human perception of time. The movie's genius was its focus on the process of decoding, the frustration, the dead ends, the exhilaration of small breakthroughs. That's exactly where we are now with Neptune. Like Amy Adams' character poring over ink blot like glyphs, scientists are staring at spectral graphs and 47-hour cycles, searching for meaning in the noise. But here's the twist: Arrival's aliens wanted to communicate. Neptune's signal, if it's even artificial, might not be a message at all. It could be leakage, like catching the hum of a distant engine without ever seeing the ship. Hollywood often assumes first contact will be grand, a glowing mothership over the White House, or a wormhole popping open like in Interstellar, yet reality favors subtlety. Consider the abyss, where the alien presence is revealed not with fanfare but with a single, glowing tendril of water. Neptune's signal fits that mold. No saucers, no invasions, just a faint pulse in the dark. It's a reminder that the universe's biggest revelations might arrive quietly, demanding patience instead of panic. But fiction hasn't just shaped our expectations, it's also led us astray. Independence Day conditioned us to associate alien tech with city-leveling lasers, while War of the Worlds framed extraterrestrials as conquerors. These narratives feed the fear that discovery equals danger. Yet Neptune's signal, if engineered, suggests something different: restraint, no aggressive probes, no demands, just energy humming along like a cosmic lighthouse. Maybe the truth lies somewhere between Close Encounters of the Third Kind's awe and Annihilation's ambiguity. The real lesson sci-fi offers isn't about predicting the future, but preparing us for its uncertainty. 2001, A Space Odyssey gave us the monolith, a silent, inscrutable artifact that pushes humanity to evolve. Neptune's signal could be our monolith, a nudge toward new physics, or a mirror reflecting our own hopes and fears back at us. Whether it's the start of a conversation or just a cosmic coincidence, one thing's clear: we're living in a story that no screenplay could have written. And that's the most thrilling part of all. History has a way of repeating itself, especially when it comes to humanity's rush toward the next frontier. When the first images of Neptune's mysterious energy signature hit the scientific community, it didn't take long for geopolitical tensions to flicker beneath the surface. On paper, NASA, ESA, and China's National Space Administration issued carefully worded statements about shared curiosity and the spirit of discovery. But behind closed doors, whispers of a new space race, one with stakes far higher than planting flags on the moon. Take the European Space Agency's sudden announcement of the Triton Dawn mission, a probe slated to launch in 2028 with a cutting-edge spectrometer array designed explicitly to analyze anomalous energy patterns. Just days later, China fast-tracked funding for its Ocean King project, a dual-purpose orbiter capable of not just studying Neptune's signal, but harvesting atmospheric samples for what their state media vaguely termed energy innovation. The timeline overlap wasn't subtle. Then came NASA countermove, repurposing the long-dormant Voyager interstellar mission infrastructure to get Odyssey pulse off the ground a full year ahead of schedule. When reporters asked about the hurry, NASA administrator quipped, "Science waits for no one." But the subtext was clear. This isn't the 1960s, though. The original space race was a two-player chess match between superpowers. Today's scramble involves private corporations, billionaire visionaries, and even nations without traditional space programs. India's ISRO shocked observers by reallocating 20% of its annual budget to develop a Neptune-capable propulsion system, while startups like SpaceX and Blue Origin began quietly acquiring patents for exotic energy extraction. The irony: cold fusion could render fossil fuels obsolete, a fact not lost on oil-rich nations suddenly investing in aerospace. Yet amid the competition, glimmers of collaboration shine. The United Nations Office for Outer Space Affairs brokered an unprecedented agreement. Any nation or entity studying Neptune's signal must share raw data in real time through an open access portal. It's a fragile détente, but a meaningful one. Scientists from rival agencies now huddle in virtual workshops, debating spectral analyses instead of political borders. "This isn't about flags anymore," said Dr. Lin Wei, a lead astrophysicist with China's deep space program. "It's about whether we're smart enough as a species to handle what we've found." Still, shadows linger: classified budgets, dual-use technologies, and the specter of weaponizing whatever's generating that signal keep diplomats awake at night. When Russia's Roscosmos abruptly partnered with a shadowy aerospace firm linked to the Kremlin's military-industrial complex, the scientific community bristled. Meanwhile, leaked Pentagon reports reveal contingency plans for securing and defending off-planet energy resources, a phrase that chills more than it reassures. The question isn't just who'll reach Neptune first, but what happens after. Will breakthroughs be locked behind patents and national security clearances, or shared to uplift all of humanity? The original space race gave us GPS and satellite communications, byproducts of competition that benefited everyone. This time, the prize isn't just prestige. It's potentially universe-altering technology, and whether we handle it with open hands or clenched fists will define our future among the stars. One thing's certain: Neptune's signal didn't just reveal a cosmic mystery. It held up a mirror, forcing us to confront who we are and who we want to become. Budgets are being rewritten overnight as the hunt for Neptune's mystery signal upends decades of space funding priorities. In a closed-door session last month, the U.S. Senate quietly reallocated $2.3 billion from defense contracts to NASA's Odyssey Pulse mission, a move one senator called the best insurance policy against getting left behind in the cosmic power race. Across the Atlantic, the European Union fast-tracked approval for Horizon Europa's most ambitious project yet, a network of deep space telescopes dubbed the Argus Array, designed specifically to monitor Neptune's energy fluctuations with unprecedented precision. Slated for completion by 2030, these orbiting observatories will feature quantum-linked mirrors capable of detecting terahertz waves at resolutions 1,000 times sharper than current tech. But it's not just governments diving in. Private philanthropists are writing checks with staggering numbers. The Breakthrough Foundation, backed by Yuri Milner and Mark Zuckerberg, announced a $500 million prize for the first team to definitively explain the signal's origin, sparking a gold rush among university labs and aerospace startups. Meanwhile, Japan's Aerospace Exploration Agency took an unconventional route, diverting funds from lunar rover programs to develop Project Haku, a swarm of microsatellites that could piggyback on commercial rocket launches to Neptune as early as 2029. The most surprising shift: traditional energy giants entering the fray. ExxonMobil's venture arm recently invested $300 million in Helion Energy's Triton core reactor, an unmistakable hedge against the possibility that cold fusion could render fossil fuels obsolete. Even Saudi Arabia's Public Investment Fund launched a space technology subsidiary with one explicit goal: secure mineral rights to novel energy sources in the outer solar system. The message is clear: whatever's pulsing near Neptune, it's no longer just a scientific curiosity. It's the new front line in the global scramble for the future. Yet amid the frenzy, small teams are making big waves with shoestring budgets. At MIT's Media Lab, graduate students built a low-cost spectrometer from repurposed MRI components, dubbed Neptune Ear, that's already detecting similar terahertz patterns in lab-grown metallic hydrogen. Their entire budget, less than $20,000, it's a reminder that while billion-dollar missions grab headlines, breakthroughs often come from unexpected corners. Whether it's national agencies or basement tinkerers, one truth unites them. The rules of the game have changed, and the players racing toward Neptune aren't just exploring space anymore. They're betting on who controls tomorrow's energy, and with it, the balance of power on Earth. The discovery of Neptune's enigmatic energy signature hasn't just shaken the scientific community, it's sent reverberations through the world's faith traditions, sparking profound questions about divinity, design, and humanity's place in the cosmos. For some religious leaders, the signal is a modern-day burning bush, a cosmic signpost pointing toward a grander intelligence. Reverend Elias Carter of the Vatican's Pontifical Academy of Sciences frames it as a revelation. Science and faith have always danced around the same truth. If this signal is the work of an advanced civilization, it only deepens the mystery of creation. After all, why couldn't God employ other hands to shape the universe? His perspective echoes the Catholic Church's long-standing openness to extraterrestrial life, a stance solidified when Pope Francis once mused that baptism might extend to beings from other stars. Yet not all interpretations are so harmonious. Evangelical pastor Daniel Reeves, host of the End Times Today podcast, warns his millions of followers that the signal could be a deception of the Antichrist, citing biblical prophecies about lying signs and wonders in the last days. His sermons have gone viral, splicing NAS, a footage with apocalyptic scripture, urging believers to view the discovery as a test of faith. Meanwhile, in India, Hindu astrologers are recalculating ancient Vedic charts, drawing parallels between the signal's 47-hour cycle and the rhythmic pulses of prana, the cosmic life force. The universe breathes, explains Guru Madhavananda. What scientists call an anomaly, we see as the breath of Brahma manifesting in new forms. Scientists of faith find themselves at a crossroads. Dr. Aisha Al-Farsi, a Muslim astrophysicist at Qatar's Space Research Institute, reconciles the discovery with her Islamic beliefs by invoking the Quran's emphasis on cosmic diversity. Surahs speak of worlds beyond our knowing, she notes. If this signal is proof of other intelligences, it only expands our understanding of Allah's creation, not contradicts it. Jewish scholars, meanwhile, debate whether the signal aligns with Kabbalistic teachings about Sephirot, divine energies that structure reality. Rabbi David Cohen of Jerusalem's Hesder Yeshiva suggests the pulse could mirror the Tzimtzum, the primordial contraction of God's light to make space for creation. Science names the mechanism, mysticism reveals the purpose, he reflects. Atheist and secular voices counter that the signal, however extraordinary, demands natural explanations before divine ones. Invoking the supernatural is a dead end, argues Dr. Liam Park, director of the Center for Skeptical Inquiry. Every mystery in history, from lightning to disease, was once blamed on gods until science uncovered the real mechanisms. Yet even skeptics acknowledge the signal's existential weight. Philosopher Daniela Ruiz writes that whether the source is natural or not, humanity's reaction reveals our collective yearning for meaning in a vast, indifferent universe. The tension between these perspectives isn't new, but Neptune's signal sharpens it. For centuries, comets and eclipses were seen as omens. Now we parse spectral data for clues. The real revelation may be this: in an age of quantum physics and deep space probes, the line between the sacred and the scientific has never been thinner. Whether the signal is a fingerprint of the divine or simply a quirk of quantum mechanics, one truth remains: it holds up a mirror to our deepest hopes, fears, and the timeless question of whether we're alone in the cosmos. Imagine flipping a switch and suddenly every home, every city, every nation has access to limitless, clean energy. No more oil spills, no more coal pollution, no more geopolitical battles over dwindling resources. That's the tantalizing promise of cold fusion, and if Neptune's signal proves it's possible, the ripple effects could redefine civilization itself. We're talking about more than just a scientific breakthrough. This is the kind of discovery that topples industries, redraws global power maps, and rewrites humanity's future. The energy sector, worth trillions, would face a seismic shift overnight. Fossil fuel giants, once untouchable, could find their empires crumbling as nations rush to adopt fusion technology. Picture Saudi Arabia's oil fields losing their stranglehold on the global economy, or entire regions freed from energy dependence on volatile regimes. But here's the catch: the transition wouldn't be peaceful. Corporate wars over patents would erupt, with tech conglomerates, energy titans, and rogue startups locked in billion-dollar legal battles. The race to commercialize cold fusion could mirror the cutthroat rivalries of the early tech boom, only with stakes far higher than smartphones or social media. Geopolitically, the implications are staggering. Whoever masters this technology first gains an almost godlike advantage. Imagine a world where one nation holds the keys to limitless energy. Would they share it or wield it as leverage? History suggests the latter. The Manhattan Project wasn't just about ending World War II. It was about securing dominance in the atomic age. Cold fusion could spark a modern-day equivalent, with nations hoarding knowledge, sabotaging rivals, or even weaponizing the technology. Some analysts fear a new fusion gap could emerge, dividing the world into energy haves and have-nots with a brutality that makes today's disparities look quaint. Yet amid the chaos, hope flickers. If handled ethically, cold fusion could be the great equalizer, a force for lifting nations out of poverty, reversing climate damage, and uniting humanity under a shared vision of progress. Renewable energy advocates dream of decentralized grids where villages in Africa or South America generate their own power with tabletop reactors, leapfrogging fossil fuels entirely. Environmentalists envision skies clearing as emissions plummet, with fusion-powered carbon capture scrubbing decades of damage from the atmosphere. The utopian vision is seductive, a post-scarcity world where energy isn't a commodity to fight over, but a universal right as abundant as air. But between that dream and reality lies a minefield of challenges. Even if we decode Neptune's signal, replicating it on Earth demands breakthroughs in materials science we can't yet fathom. Superconductors, quantum catalysts, containment fields, each hurdle could take decades to clear, and let's not forget the human factor. Progress moves at the speed of trust, and after decades of cold fusion hoaxes and hype, the public skepticism runs deep. Winning hearts and minds might be harder than cracking the physics. The truth is, we stand at a crossroads. Neptune's signal could be the spark that ignites an energy revolution, or a mirage that fades into cosmic noise. But one thing's undeniable: the moment we crack cold fusion, humanity crosses a threshold. The question isn't just whether we can harness this power, but whether we're wise enough to wield it without repeating the mistakes of every energy revolution that came before. The universe might have just handed us the keys to the future. Now we have to prove we're ready to turn them. The clock is ticking for humanity's next great leap into the unknown, and the roadmap to Neptune is taking shape with an urgency rarely seen in space exploration. Leading the charge is NASA Odyssey Pulse, a mission born from repurposed components of the scrapped Triton probe, now slated for launch in early 2027. Unlike traditional planetary missions focused on mapping or atmospheric studies, Odyssey Pulse carries a singular obsession. Its suite of instruments is fine-tuned to dissect that enigmatic energy signature down to the quantum level. Imagine a cosmic detective armed with spectral analyzers so precise they could distinguish between natural phenomena and engineered output with 99.9% certainty. The probe's trajectory will slingshot around Jupiter for a gravity assist, allowing it to reach Neptune's orbit by 2033, a blink of an eye in interstellar terms. Not to be outdone, the European Space Agency's Triton Dawn represents the most ambitious deep space venture in ESA history. Scheduled for 2028, this nuclear-powered orbiter boasts an innovative echo-mapping system designed to trace energy pulses back to their source with centimeter-level accuracy. But here's the game-changer. Dawn will deploy 2 penetrator probes to punch through Triton's icy crust, searching for subsurface energy anomalies that might mirror Neptune's signal. These bullet-shaped landers, hardened to survive -200-degree surface temperatures, carry tiny drills capable of sampling potential cryovolcanic vents, a deliberate gamble that whatever's causing the signal might leave traces on its nearest celestial neighbor. Meanwhile, China's National Space Administration has remained tight-lipped about specifics, but leaked blueprints suggest their Ocean King orbiter is being built for stamina rather than speed. With a projected arrival date of 2035, its slower trajectory allows for a heavier payload, including a prototype quantum harmonizer that claims to stabilize cold fusion reactions in microgravity. While Western scientists remain skeptical about these claims, the mere inclusion of such experimental tech signals China's intent to not just study the phenomenon, but potentially harness it. Private entities are joining the scramble too. SpaceX's recently unveiled Neptune Starcatcher program aims to deliver a swarm of suitcase-sized sensor probes by 2030, hitching rides on Falcon Heavy launches. These minimalist CubeSats will form a distributed sensor net around Neptune, triangulating the signal's origin with unprecedented resolution. Elon Musk's characteristic bravado shone through when he tweeted, "If there's a cosmic energy jackpot, we're bringing drills," hinting at undisclosed mining tech aboard the probes. The timelines overlap in fascinating ways. By 2033, humanity could have 4 separate spacecraft converging on Neptune, each approaching the mystery from different angles, each with capabilities the others lack. It's a coordinated rush reminiscent of the Mars rover missions, but with stakes exponentially higher. The data stream coming back won't just be about atmospheric composition or gravitational fields. It might contain blueprints for rewriting physics textbooks or even, if the wildest hopes prove true, the first confirmed evidence we're not alone in crafting technology. Yet the real intrigue lies in what these missions haven't announced publicly. NASA budget requests include a classified line item cryptically labeled Pulse Response, while ESA documents reference an active engagement package on Triton Dawn whose specs are conspicuously redacted. Are these merely sensitive scientific instruments or something more provocative? The coming years will reveal whether humanity's first interstellar conversation begins with a handshake or by accidentally pressing cosmic buttons we don't yet understand. One way or another, that faint pulse from the solar system's edge is about to get the closest examination in history. From the first flicker of that impossible energy signature near Neptune to the global frenzy of scientific theories, private ventures, and cultural upheaval it sparked, this mystery has taken us on a journey far beyond the icy edges of our solar system. We've stared down the data, a signal pulsing with the precision of a metronome, matching no known natural phenomenon, yet bearing the hallmarks of a technology we've barely dreamed of. We've weighed the possibilities: exotic physics, alien engineering, or something even stranger, and watched as nations and billionaires scrambled to decode it. The stakes couldn't be higher. Crack this puzzle and we might unlock limitless clean energy, rewrite the laws of physics, or even answer the universe's oldest question: are we alone? But beyond the science, Neptune's signal holds up a mirror to humanity itself. It's exposed our hunger for discovery, our fear of the unknown, and our relentless drive to push boundaries even when the truth might upend everything we think we know. Whether this turns out to be a cosmic fluke or the first whisper of something greater, one thing's certain: the universe still has surprises up its sleeve. And that's the real magic here, not just the what, but the why. Why now? Why Neptune? And why us, this tiny, curious species, to stumble upon it? So where do we go from here? The probes are launching, the labs are buzzing, and the world is watching. But this isn't just a story for scientists or governments, it's yours. Imagine being part of the generation that solves this, or better yet, the one that learns to live with its answers. That's why we want to hear from you. What do you think is behind Neptune's signal? A natural wonder, alien tech, or something no one's even considered yet? Drop your theories in the comments. We're all detectives in this cosmic mystery. And if you want to be the first to know when the next clue drops, hit that subscribe button. The universe isn't done talking. Let's make sure we're all here to listen.